Live from historic Fort Andros in downtown Brunswick, your way to wake up on the Midcoast. The Midcoast Morning Buzz. Richard Kazimer, Jim Bleikamp, Radio 9, WCME.
This evening at 6 o'clock at Bowdoin College Kresge Auditorium Visual Arts Center, there will be a lecture entitled Mathematics and the Melting Polar Ice Caps. Dr. Kenneth Golden, professor of mathematics at the University of Utah, will be conducting the seminar. Dr. Golden will discuss the mathematical models of composite materials and statistical physics that are being used to study key sea ice processes and the advance on how sea ice is represented in climate models. The work is also helping to improve projections of the fate of Earth's ice packs and the response of polar ecosystems. Dr. Kenneth Golden is our guest today. Dr. Golden, you couldn't get girls in high school either, huh? I empathize with you, brother.
It's rough being into math.
It is. Thank you for coming on the show today. What the hell are you talking about? What is this all about? I mean, look at me. Come on now. This is really serious stuff. I mean, if ever do the math applies, you're the guy, right?
That's right.
So explain to us what it is this is all about. And this is, the statistical data is very important in the chronicling the melting of the ice caps, is it not?
Right. So the summer Arctic ice pack is melting at a quite a rapid rate. In fact, much more rapidly than most of the world's best climate models are able to predict. And so ultimately we're trying to better study more intensively, more rigorously, more mathematically the role of sea ice in the climate system to try to represent some of these processes that are not so well understood, not so well represented in climate models, which accounts for part of their inadequacy, at least the last round of climate models. And so we're trying to ultimately improve these models to make better projections of the fate of Earth's sea ice packs, as well as the rich ecosystems that live there.
What is actually happening? It's undisputed that the world is getting warmer for whatever reason. We know that the general consensus is that it's man-made that's doing it. But this has happened. You'll get some people on the other side of the issue to say, well, this happens periodically in the history of the Earth, although millions of people didn't inhabit most of the coastlines of the Earth at the time. So is the sea level going to rise? I just read the other day that the sea levels are actually receding. So what is going to happen here, and what is the effect on society when these ice caps melt? And when is it going to happen? Is that what your data is going to project?
Well, okay, we actually study sea ice, which is frozen ocean water, which is in isostatic balance with the ocean.
It's already displacing.
Okay. Exactly. So melting sea ice doesn't directly affect the issue of sea level rise. That's more the melting of the great land ice sheets, such as the Antarctic ice sheet, the Greenland ice sheet, and when that fresh water is transported through calving of icebergs and other processes into the ocean, that's how sea level rises. However, the indirect effect of the sea ice melting is that as that sea ice pack recedes and is no longer like a white surface, which is protecting, say, for example, the Arctic Ocean from incoming solar radiation, well, that means that you're further warming the oceans, which means that that warmer water is sort of lapping up against these ice shelves, the periphery of the Great Land ice sheets. And so ultimately, there will be even increased melting of the Great Land ice sheets indirectly through this dramatic melting of the Arctic sea ice pack.
So are you the guy that people come to and say, we can theorize that X, Y, and Z is going to happen once the sea ice has melted, but we don't know when it's going to happen? You're the guy they go to and say, give me some data as to I can make a further prediction or a concrete prediction on this, so that I'm not standing there with my hands in my pockets and people are saying, well, you know, you don't know if it's going to happen next week or 1,000 years from now.
Ultimately, one of the goals is to provide policymakers with better information about the time frames involved, the extent of changes in our climate, as well as, the ice pack and so on. I'm a professor of mathematics, and in fact, my background is really in composite materials, and sea ice is a composite material of pure ice with brine inclusions, and we try to get into all the gory details of the properties of the ice and the kinds of processes that are inherent in its melting, and to try to better understand these processes. And then I essentially do a lot of mathematics, but also field work. we go to the Antarctic, we go to the Arctic, and to try to get measurements to validate our models as well as to further improve and further develop our models. And so and then that information, that kind of these mathematical theories and formulas and models that we create are then fed on to the large-scale climate modelers, such as my colleagues at Los Alamos or NCAR, the National Center for Atmospheric Research. These are the people that actually write these massive million-line computer programs. And so there's really another link in the chain in that we pass our information onto them, and then they ultimately incorporate our results into the climate models.
Just a thought. It would seem to me, of course, a lot of people, particularly the skeptics, are inclined to see climate change in terms of theory. But it would seem to me, based on all I've read and heard, that the melting of the polar ice caps that you're involved in documenting and measuring, that's about the best textbook case example, visual, discernible evidence of climate change.
Exactly. In fact, I often try to make that point in my lectures, particularly the public lectures I give, that, if you hear that Earth's temperature has risen by 1 degree or 2 degrees over, a number of decades, it may...
But that's significant also.
That is significant, but it might be, but you might think of your own self and your own body and your own experience on a day-to-day basis, how temperature fluctuates and so on, and it might be easy to sort of write it off. But when you are visually confronted with satellite pictures, images of, 20 years ago at the September minimum, where, most of the Arctic basin, most of the Arctic Ocean was covered with sea ice at its minimum. And now you fast forward 20 years later to 2013. In fact, on September 13th of 2012, the day before we left for our last Antarctic expedition, it was the record minimum that's ever been measured during the satellite era. So basically more than half of that summer Arctic sea ice pack is now gone. It's a very striking visual image.
Must be an absolutely awesome thing to witness up close.
Absolutely. I mean, I've been very, very fortunate, particularly as a professor of mathematics. I've now been to the Antarctic 7 times, starting in 1980, actually, when I was an undergraduate. And I've been to the Arctic 8 times. In fact, we're leaving for the Arctic in less than a month for our next expedition. And, and particularly in the Arctic, over since I was really going regularly in about 2000, I've really seen real changes, up in Barrow, Alaska, the northernmost point of the United States, and to see the changes that have occurred there.
It has to be frustrating for you to be compiling all this data and traveling to the ends of the earth and solidifying this data, and then have people on all sides of the fence say, well, hey, that's the way it goes, or actually saying, well, no, you're lying. You're doing it for profit. I mean, how much money is there in what you're doing? You didn't roll up here in a limousine. I don't get it. It's like people disputing the cause of the fire while they sit in their living room and it's burning around them. I don't understand this.
I think part of it is people have their own agendas. They have their own livelihood to look out for, and if they see that being threatened, they'll respond in a certain way, whether or not it might be completely true or not. And it is sad to me. It is particularly sad to see something like just the most basic, what I consider to be the most basic science, become a political football. Yeah. It is unfortunate. I mean, from my standpoint, the science itself, it's kind of, I don't know, it's hard to dispute when, say 97, 98% of the world's leading climate scientists at least agree on what's going on.
And the point must be made, and I've run into this over and over again, and I've documented it, that many, many, many of the 3% who are disputing the majority consensus or dissenting in some way, shape, or form are on the payrolls of energy companies.
Yeah, that may well be the case. I don't know.
Reality, it is.
Yeah.
Well, that's what we were discussing before we went to air, is that I was going to ask you the question about the climate change debate. And, Jim takes exception to that. There is no debate. I rack my brain as to thinking, when was the last time I ever heard or read about a debate with a scientist such as yourself and somebody who has facts to dispute your undisputed information? It doesn't exist. So it's media created.
From my perspective, there's sort of the 3 basic issues here. There's the basic science of whether or not the climate is changing. I think that's pretty much undisputable, certainly from my perspective. Then the question is, well, what's causing it? Yeah. And, certainly I do believe, and the best evidence that I've seen suggests that man's input of CO2 into the atmosphere has played a significant role in what we are experiencing now. Again, that is, I think, not that controversial, although that unfortunately has become generated quite a bit of controversy. Then there's the third issue, which is what should we do about it? That is a political issue. Yeah. I can see lots of debate there. That policymakers, this affects lots of people, how we spend our resources, how, what kind of restrictions we place on emissions and so on. So that I do believe that is a perfectly legitimate place for political debate. But the basic issue of whether or not the climate is changing, and in particular, sort of what's going on, what's behind it, I find that very unfortunate that there is so much debate, and in fact so much uninformed debate about that.
One other thing, just on a personal note, how is it that a mathematician gets into all this is really what has become a specialty for you?
That's right. And that is unusual for a math professor,
yeah.
for sure. I mean, I think I'm one of the only 1 or 2 or 3 math professors of mathematics in the world that actually goes to the polar regions and really does extensive field experiments on the ice. Actually, it was kind of the other way around. I was really always very interested in skiing when I was a little kid. And then I went on an NSF summer science training program after 11th grade.
It sounds like National Science Foundation.
National Science Foundation, yes. And I started studying past climates, paleoclimate, and melting of snowbanks. And then my senior year of high school, I worked at NASA studying satellite images of Antarctic sea ice. And then when I went to Dartmouth fairly close to here, up in New Hampshire, for an undergraduate, I did study sea ice and published my first published work in Journal of Geophysical Research on remote sensing of sea ice. But I treated it as a composite material. But in my college years, I fell in love with the interface between mathematics and physics. And so when I went to get my PhD, it was in mathematics, and I had planned on leaving the sea ice world. Even though I loved it, I'd been to Antarctica, but I just so fell in love with the theory of mathematics and physics. For the next 10 years, I became quite pure in studying those kinds of things. When I moved to University of Utah in about 1991, I got some invitations to re-enter the sea ice world, and it turned out, fortuitously, that so much of the heavy-duty mathematics and mathematical physics I had studied as kind of a purer mathematician was absolutely relevant and critical for advancing sea ice research.
Well, I heard you say in there that you were working for NASA while you were a senior in high school.
Yes, that's not being paid, but going there 2-3 days after school and working with a very wonderful, prominent scientist.
I want you to know that when I was a senior in high school, I was learning to dress myself.
I was never a senior in high school. You make me sick. You make me sick, Dr. Golden. You really do. So tonight, Dr. Kenneth Golden, the professor of mathematics at the University of Utah. He's going to be speaking tonight at 6 o'clock at Bowdoin College Kresge Auditorium Visual Arts Center. The lecture is entitled Mathematics and the Melting of Polar Ice Caps. Professor Golden, thank you so much for coming in. You're a wonderful man. You're doing God's work here, but there is no God. We know that. So.
Well, thanks so much for having me. I really appreciate this opportunity.
Radio 9 WCME.